Hi scholars, this is Miss Gardner from Riverside High School. So today we are going to do a brief introduction to solutions and molarity. If you were in my class before we left on this break, we did one lesson on solutions where we made lemonade in class. So just to recap, solutions are just a mixture of two or more substances that is uniform throughout. So we've actually heard of this before last semester when we talked about things that were considered a homogeneous mixture. So homogeneous meaning uniform all the way through. So solutions are also made of a solute and a solvent. Those are the two main parts we're going to be discussing. The solute is the substance being dissolved, so that is the little orange particle over here. And the solvent is the substance doing the dissolving. So usually that's the liquid when we're thinking about this in terms of solutions we make in lab. If we are making lemonade, which we did in Miss Gardner's class, what would the solute be? Take a moment to think. And it's going to be the lemonade powder. All right, so the solvent in this case will be the water. So that is the part that does the dissolving. We can speak about solutions in terms of their concentration. So when we made lemonade in class, we had one that was very sweet, so that one was very concentrated, and we had one that was not very sweet. It was not very concentrated. So we describe that by taste, but we can also describe that quantitatively using molarity. So concentration, it just refers to the amount of solute that's dissolved in a solution. And molarity is specifically considering moles of solute per liter of solution. So the equation for molarity down here, capital M, that's the symbol for molarity, it equals N for the number of moles divided by volume, or liters of solution. And we can simplify that as moles per liter. So let's do some practice problems. So here's where you're going to need your calculator, and we may need our periodic table to calculate molar mass. All right, number one, you have 2.3 moles of sodium chloride and 0.45 liters of solution. Find the molarity. Well, I'm going to rewrite my equation here. Capital M equals moles per liter. I'm going to plug in my numbers, 2.3 moles in 0.45 liters. I divide. I get 5.11 molar. That's how we would describe that. It is a 5.11 molar solution. That capital M also just means moles per liter. There are 5.11 moles per liter of solution. All right, number two. Find the molarity if 1.2 moles of calcium carbonate are dissolved in 1.22 liters of solution. Again, I'll use my same equation. M equals moles per liter. I will plug in 1.2 moles divided by 1.22 liters, and I should get 0.98 molar solution. All right, make sure you are writing these down. You will need to submit these in the Google form later. All right, number three, find the molarity of 98 grams of sodium hydroxide are dissolved in 2.2 liters of solution. Well, we don't have moles in this equation, but how do we convert between grams and moles? Well, we know how to do that. We just need the molar mass. So before I can calculate molarity here, I'm going to convert 98 grams to moles. So that requires the molar mass of NaOH. So I'm going to add 1 sodium plus 1 oxygen plus 1 hydrogen. I got those values from my periodic table. And the molar mass of NaOH is 40.0 grams per mole. Make sure you're writing units when you write down your molar mass. All right, so we'll do factor label to convert. I'll start with 98 grams. I'm going to divide by the molar mass. Notice how my grams of NaOH will cancel, and I'll be left with 2.45 moles of NaOH. All right, now I have moles. I can just go ahead and plug this into my molarity equation. 2.45 divided by 2.2 liters, and I will get 1.11 molar solution. All right, so that one required one extra step before we could calculate molarity. All right, number 4. Find the molarity if 120 grams of calcium nitrite are dissolved in 0.240 liters of solution. Again, we need to find the molar mass before we can calculate molarity because we're given our amount in grams. So the molar mass of calcium nitrite, 40.08 plus 2 nitrogens plus 4 oxygens. So notice that 2 around my nitrite, that's going to distribute into my parentheses. So 2 times 2 gives me 4. 2 times 1 gives me 2 nitrogens. All right, so I simplify that, and I'll get a molar mass of 132.1 grams per mole. Now I can do my factor label. I start with 120 grams of calcium nitrite. I'm going to divide by the molar mass, make sure my units are canceling, and then I will get 0.91 moles of calcium nitrite. Now I can plug that into my molarity equation, 0.91 moles divided by 0.240 liters. And I should get a molarity of 3.79 molar. Okay, so we can rearrange the molarity equation to solve for the other variables. So our starting equation, capital M equals moles over liter. If we wanted to solve for moles, well, we can just rearrange algebraically. So we'll multiply each side by L. These ones will cancel out on the right side. And then I'll just get moles is equal to liters times molarity. I can solve for L. I'm going to just start with my equation for moles. Now to solve for L, I need to divide each side by molarity. Those will cancel on the right side, and then my liters is this equal to moles divided by molarity. All right, so let's go ahead and write those in our notes so we have those rearranged equations available for us. And let's use them to solve number 5. How many liters of solution are needed to make 0.0054 moles of sodium carbonate in a 0.12 molar solution? All right, so I have moles over here. I have molarity. I'm looking for liters, so I'm going to use this equation. So liters equals moles divided by capital M, or molarity. I will just plug in my numbers, 0.0054 moles divided by 0.12 molar. Simplify, and it will be 0.045 liters. All right, let's try number 6. Oops, there's a typo here. How many moles of solute should be added to make 2 liters of a 6 molar HCl solution? All right, so I have liters here. I have concentration or molarity here. I'm looking for moles, so I'm going to use this equation. Moles equals liters times molarity. 2 liters times 6 molar, 12 moles. All right, so number 7, I'm going to call this one a challenge problem. How many grams of solute are necessary to make 0.75 liters of a 0.25 molar NaCl solution? All right, so it's not super clear which of these equations I'm going to use yet, but look at what we're given. We have 0.75 liters and we have 0.25 molar. So I have everything to solve for moles. And then can I convert moles and grams? Yeah. We just need our molar mass. So first let's solve for moles. So I'm going to use this equation. Moles equals liters times capital M. 0.75 liters times 0.25 M equals 0.1875 moles. Now that I have moles of sodium chloride, I can convert that to grams of sodium chloride. So I need the molar mass before I do that. So I'm going to add the mass of sodium plus the mass of chlorine. That will be 58.44 grams per mole. Remember, keep those units with your molar mass. It's a conversion factor. So now I'll set up factor label. 0.1875 moles NaCl. Now I need moles to cancel, so now I'm going to multiply by the molar mass. So my moles will cancel. 58.44 times 0.1875. And I'm going to get 10.96 grams of sodium chloride. All right, so from here, I want you to go ahead and do the practice problems 8, 9, and 10 on your own and submit those to the Google form. All right, if you have any questions, please reach out and we will do a quick summary on Thursday on our C day, but there will be no new content on that day. All right, have a good day, scholars.